I'm Leela, and in this video, we are going all the way back to where AI actually began. Have you ever wondered what's actually happening inside AI? Is it thinking? Is it guessing? Is it magic? It's none of those. In the next few minutes, we are going to walk through the real building blocks of AI. 9 key concepts, each explained in plain language with a real world example and a diagram. By the end, you'll know exactly what people mean when they say machine learning, neural network, or AI agent, and why AI can do amazing things and still get things confidently wrong. Here is our roadmap. We'll start with traditional programming, the real world before AI, then machine learning and deep learning, where machines start finding their own patterns, then generative AI and AI agents, the technology behind tools like chatbots and automated assistants, and finally, we'll open the hood and look at the parameters, training data, and the black box problem, plus 5 common myths about AI. Let's get into it. First, traditional programming. This is the original approach. A human writes every single instruction the computer will follow. Take a tax calculator. A developer writes a rule like if income is above $80,000, apply a 22% tax rate. That rule will run correctly forever. But the moment a new tax law is introduced, the software can't adapt on its own. A human has to go back in and rewrite the code. Powerful when the rules are complete, useless the moment they are not. That limitation is exactly what machine learning solves. Instead of a human writing the rules, we give the machine thousands of examples and it finds the patterns itself. This is the shift that changes everything data in, rules out. A great example is a spam filter. Nobody sat down and coded a rule for every scam email ever written. Instead, the filter was trained on millions of emails already labeled spam or not spam, and it learned on its own which words and patterns tend to signal spam. Now let's go deeper. Literally, deep learning is machine learning with many stacked layers of pattern finders, each layer building on what the last layer found. Think about recognizing a cat in a photo. The first layer detects edges and simple shapes. The next layer combines those into textures like fur. Later, layers combine textures into parts, ears, whiskers, and the final layer says that's a cat. It's pattern within patterns within patterns. The structure that makes deep learning possible is called a neural network. An input layer, one or more hidden layers, and an output layer, all connected by weighted links. It's loosely named after the brain, but don't let that fool you. It works nothing like one. A classic example is handwritten digit recognition. Pixels of a handwritten 7 go in. Hidden layers detect strokes and curves, and the output layer picks the most likely digit 0 through 9. Now, here is where things get really interesting. Generative AI doesn't just recognize patterns, it constructs brand new content, text, images, audio, even code, built from everything it observed during training. Ask it for a two-line poem about the ocean at night, and it composes original wording on the spot. That exact sentence never existed before this moment, but because it's generating, not retrieving, it can also produce something that sounds confident and is completely wrong. The next step up is the AI agent, AI that moves from responding to acting. An agent plans a sequence of steps, decides which tools to use, and pursues a goal with some autonomy. Picture a customer support agent handling a refund request. It checks the order status, verifies the refund policy applies, processes the payment reversal, and sends a confirmation email, choosing each step itself. So, what's actually inside these systems? Parameters are the billions of tuned numbers inside a model. Think of a mixing board with countless knobs. During training, every knob gets nudged slightly over and over until the combined settings produce useful outputs. These numbers store statistical relationships. They are not facts, they are not knowledge, they are weights. And where do those numbers come from? Training data. The examples the model was actually shown books, websites, images, code, articles, and more. Here is the key limitation to remember. A model can only ever reflect what was in its training data. If your topic is barely represented, the model will be noticeably weaker when asked about it. Put parameters and training data together at massive scale, and you get something even the builders can't fully explain the black box. Picture a loan application that gets automatically denied. Engineers can see which patterns resemble patterns linked to rejections during training, but they often can't point to one clean reason why. It's opaque, but it is not magic, it's arithmetic at an enormous scale. It knows when, it doesn't know why. Let's clear up 5 common myths. It understands your question. Actually, it matches patterns in your words to predict a likely response. Second one, it knows facts. Actually, it stores statistical relationships between words, not your verified knowledge. And then the third, it thinks before answering. Actually, it generates the next word, then the next based on probability, and then it makes decisions, but actually it produces outputs from criteria that humans set, and it gets smarter on its own. False. It stays fixed until humans retrain it with new data. Let's put it all together. 5 steps, each one more capable than the last, and each fragile in a brand new way. Rules break when reality changes. Machine learning only covers what its data contains. Deep learning finds deeper patterns, but is still bound by that data. Generative AI can produce something brand new and be confidently wrong, and AI agents can act on a goal without understanding why. Inside every single one of these systems, remember there is no little mind in there, just parameters shared by training data. That's the real story of AI. Not magic, not a mind, just an evolving staircase of pattern finding, built and shaped entirely by human choices. Thanks for watching. If this helped make AI a little less mysterious, consider following for more breakdowns like this one.